Hi, this is Anton from the Terra team. Welcome to the second COVID-19 Workspace tutorial. Previously, we showed you how to fetch GenBank SRAs using the Fetch SRA to BAM workflow and how to assemble FASTAs from unaligned BAMs using the AssembleRef-based workflow. Today, we'll cover how to use the SARS-CoV-2 next strain workflow in Terra. This workflow uses NextStrain's Augur Bioinformatics Toolkit to produce a phylogenetic tree you can render with NextStrain's auspice visualization tool. Let's navigate to the COVID workspace now. In the Workspace dashboard, you'll find details about each workspace workflow. If we scroll down, we see details for the SARS-CoV-2 NextStrain workflow. This allows us to take a set of FASTA files and metadata files for SARS-CoV-2 sequences and produce phylogenetic trees we can visualize for downstream analysis. While you can use any FASTA and metadata file you want, provided they're appropriately formatted, we're using open-source FASTA files pulled from GenBank, using the SARS-CoV-2 GenBank ingest workflow. We're not going to show you the GenBank workflow today, but you can reproduce the tutorial FASTA and metadata file following the step-by-step instructions linked in the dashboard here. To run the NextStrain workflow, we need some input files, which we're going to pull from a Terra data table. Let's take a closer look at some of the input files now. Click on the data page. You'll see multiple data tables, such as NextStrain build, a sample and sample set data table. In the last tutorial, we used the sample and sample set data tables to assemble FASTA files from unaligned BAM files. Today we're using the NextStrain build data table, which contains the inputs needed for the SARS-CoV-2 NextStrain workflow to run Augur. In addition to inputs, this table contains pre-generated workflow outputs, so that you can explore those as well without running the workflow. Let's hide the output files so that we can focus on the inputs. Select the gear icon, deselect the files, and then choose the inputs. Now let's look at the table. The table's first column is an ID column, which we can use to identify our different builds. For example, we have a build for Massachusetts data and a build for Alabama data. The second column contains the auspice config file. This is an optional file used to set up your tree in the auspice browser. Before you begin your workflow, it's important to think about how you want your phylogenetic tree to look and the criteria you want to use to explore the tree. This file allows you to customize your visualization. Often, users get to the end of the workflow only to find that they don't like their tree format. They'll need to update their auspice config file and then rerun the workflow, which can be time-consuming. So it's worthwhile thinking about this ahead of time. Let's take a quick look at this file, and then we'll look at an example tree in Auspice and how the tree features relate back to the config file. We can preview this file in Terra by clicking the link. We see a title with different institution names and links, a group of colorings that we can use for different metadata criteria, equating to color by drop-down options in the tree, default display settings, how we want the tree to look when we first open it in Auspice, geo-resolutions, panels, and filters. Let's look at an example tree in Auspice to better understand how this config file works. Here's a sample phylogenetic dataset we're viewing in Auspice. Let's walk through the different features. At the top of the page you can see a title. This is the same title we listed in the config file. In the middle, we see our phylogenetic tree, colored by state by default, using the default settings in the config file. To the left, you can see different options, such as the date range for when samples were collected, filtering criteria, tree options, map options, and panel options. While some of these options are taken from the metadata that accompanies our FASTA files, you'll notice several criteria were specified in our auspice config file, such as filtering and panel options. Let's return to the data table and look at the next input, the build file. The build file contains different options for subsampling our sequences. Our example FASTA file contains all the SARS-CoV-2 sequences pulled from GenBank, but we don't want to focus on all those sequences. The build file is in YAML format. Examples of the YAML format can be found in the next strain documentation. This is the same format convention that the CDC follows. Let's take a look at this file, which I have open in my text editor. There are several different builds listed in the file. For example, we see Massachusetts, Massachusetts weighted, New England, etc. The build we're using today is the Massachusetts one. When we run the SARS-CoV-2 next strain workflow, we not only specify which build file to use, the one I'm showing you, we also specify the exact build within the file we want to use. For this tutorial, the name of that build in the build file should match the build ID in the first column of our Terra data table. For example, we have a row with an ID Massachusetts, which we'll be using to call the Massachusetts build in the build file. If I want to make a new build, for example, Massachusetts weighted, I could make a new row in my table with the ID Massachusetts weighted and use the same build file. I would also want to update the auspice config file for each new build so that the title on the tree is appropriate. The next column in the table is colors TSV, which we can preview in the Terra data table. The colors TSV is a tab-separated file that allows you to specify hex codes for colors you want to use for certain geographical locations. The next input is an optional description file for the project, written in Markdown. This can be used for acknowledgments, for example. Next, we have your concatenated FASTA file containing all of your sequences of interest. This can be only one combined FASTA file, like the GenBank one we're using today, or multiple FASTA files, if that's better for your setup. Again, for this tutorial, we created this combined FASTA file using the SARS-CoV-2 GenBank ingest workflow, which you can find in this workspace. The last input we want to highlight is the metadata TSV accompanying the FASTA file. This tutorial metadata file, along with the GenBank FASTA file, was also created using the SARS-CoV-2 GenBank ingest workflow in this workspace. You can have multiple metadata files as input, provided they are correctly formatted. This workflow properly formats the metadata file to meet next strain's requirements. If you're bringing your own metadata file, it needs to conform to the next strain augur guidelines. You can find these guidelines in the next strain documentation. We encourage reviewing this documentation before starting the workflow. Now that we understand some of the input files, let's take a closer look at how we can configure the workflow to use these inputs. Let's go to the Workflows page and select the SARS-CoV-2 next strain workflow. We're redirected to the Workflow Setup page. In step 1 of setup, we need to select a root entity data table. That's the data table containing the FASTA file we want to analyze. Make sure the next strain build table is selected. Next, we select the specific data, in this case build, we want to analyze, which is our Massachusetts build. Once you've selected the data, click Save. Next, we configure our inputs. Scroll to the bottom of the Setup page to look at the Inputs tab. Notice we could also look at the whittle script here, but for now, let's just look at the inputs. Required inputs are in bold, whereas optional inputs are in italics. As we're looking at inputs, you'll notice there are more inputs, mostly optional, than what we'll set up today. If you have questions about the inputs we aren't using, you can learn more by exploring the whittle script or by viewing the next strain documentation for augur. We're going to call many of our inputs from the Terra data table we explored earlier. To call an input from a column in the root entity data table, our next strain build table in this case, we use the this dot syntax. For example, our FASTA file is in the column with genomes_FASTA in the header. So we assign the variable to this.genomes_FASTA. Terra will know to grab the file from that column for our selected data. We can confirm the correct syntax for the remaining inputs. Notice that some of the inputs we're not pulling from the Terra data table, Let's review those quickly. The remove references is a next strain parameter that is false by default. But to run the example GenBank FASTA in this tutorial, it must be set to true. The inputs clock rate through keep root are default next strain parameters, and you can read more about them in the next strain documentation. We could have put them into a data table, but we manually wrote them for today's tutorial. The root for our phylogenetic tree is the Wuhan SARS-CoV-2 reference FASTA. The last file you see is that auspice config file, which we're pulling from the data table. Let's select Save to save our inputs. Now let's assign our workflow outputs. We want to write the outputs to our root entity data table too. Just as we did for inputs, we can use the this dot syntax to create columns for these outputs. We can choose a custom name for the column headers, or alternatively, we can select the Use Default option. This makes the output variable names the column headers. When we're ready, we select Save. Now we can launch our workflow. After launching, we're taken to the Job History tab, where we can monitor the progress of our workflow. When the workflow is successful, it will have a green check mark. After the run, our outputs, including our auspice file, will be written to the next strain build table. Let's grab an example auspice input file and see how to load it in auspice. Remember that our next strain build table contains pre-generated outputs. I'm going to use the gear icon again to show all columns. Scroll to the auspice input.json column and select the file link. Download the file, open the auspice browser in a new browser tab, go to auspice.json, and drag the auspice input file into the browser. You should now see your phylogenetic tree. This concludes the COVID tutorial on using the SARS-CoV-2 next strain workflow. For more information about Augur, including inputs, check out the next strain Augur and auspice documentation. For more information about Terra, be sure to check out the Terra Knowledge Center at support.terra.bio. Thank you for listening.